Hello and welcome to episode 5 of JNSQ ARC. Today we'll be making some exciting milestones as we continue our exploration of Minmus. The first item on the agenda here is to finally wrap up this Minmus probes program strategy with one last spacecraft. We already have an orbit here. This is the same probe lander we've used for the previous two missions, and the mission plays out pretty much the same way, so I won't go into too much detail. I started by planning a burn that would put us on course to fly over Minmus's poles, again using the difference between Minmus's inclination and the ship's launch inclination to our advantage. As we approach Minmus, I planned another maneuver to capture the craft in orbit around the body, which also helps double check that we still have enough fuel left. The course of the orbit travels directly over some of Minmus's flats, and since we haven't landed a probe there yet, the obvious choice was to deorbit the probe right away to land at this very advantageous location that is, as the name would suggest, completely flat. After a gentle and well-controlled descent, we touch the probe down softly, completing our lofty robotic exploration goal, with Kerbin looming just above the horizon. After taking a quick gander around, I decided to just head back into the tracking station to wait for the data to transmit. I don't recall if I had this mod installed last episode, as I'm pretty sure I only remembered it existed more recently. But the enhanced tracking station is wonderful for the amount of clutter you can easily accumulate with all your vessels over time. With that finished, I had a look at our contracts. There weren't any particularly appealing contracts available, but we can do a mission to knock off a couple of our active contracts while scraping up a bit more science to help us get the parts we need to visit Minmus with a manned spacecraft. There are two contracts that can be knocked out here. Collect science data from space around Minmus, and the Return to Kerbin from Orbit of Minmus objective from the Explore Minmus contract. I had to take a browse through the available experiments to see what we could actually put on this probe, and I eventually settled on the Survey Interplanetary Trash Experiment, or SITE. This experiment can be run on any body except the Sun, and can run once in low space as well as run for every biome in high space. There are two other probe-specific experiments we have unlocked, but the LITE or LITE we've already ran for both Kerbin and Minmus, and the MITE or MITE can only be run around atmospheric bodies. Despite the data size of the SITE experiment, I'm only putting the wimpy fixed antenna communitron on this craft. Why, you may ask? Well, first, the experiment takes an hour to complete, so the data rate isn't actually that high. Second, the point of this mission is to retrieve the craft, so in the unlikely event that the recorded data has not been transmitted even by the time the vessel makes it back to Kerbin, it should be retrievable by recovering the module at the top of the spacecraft. Speaking of spacecraft structure, I'll dive a bit into this vessel. The launch stage is comprised of this central liquid-fueled column driven by a swivel, which is aided by two thumper SRBs strapped onto the side. The swivel is necessary at launch, but is very quickly throttled down as the craft's TWR rises, so the delta V numbers are a bit misleading in that very little of the center stage's fuel is actually consumed while the solid rocket boosters are still attached. The center stage provides the real meat and potatoes kick to the spacecraft's speed once the gravity turn is mostly completed and the craft needs to accelerate horizontally as quickly as possible. The upper stage consists of a small fuel tank with the Terrier vacuum engine, and this stage will complete the orbital insertion as well as provide all of the fuel to travel to Minmus and back. At the top of this stage is a recovery module which contains most of the expensive bits of the spacecraft, including the probe core, batteries, reaction wheel, and antenna. The former three components are all securely housed in the 1.25 meter service bay, while the antenna is attached on the outside along with the parachute. The large weight of SRBs in comparison to the center liquid stage made this craft rather unwieldy, and I had to fly it using the Smart ASS rather than use the gravity turn utility. The main sticking point is that the liquid engine needs to be firing for the craft to have a desirable thrust-to-weight ratio on launch, but this ratio rises very rapidly as the solid fuel begins to burn off, and as a result the throttle needs to be cut back much earlier than the basic ascent parameters in the gravity turn utility allow. The good part about this is that it allows the liquid fuel to be preserved until the solid boosters have been discarded, meaning that the more efficient liquid engine can use all of its energy only to accelerate itself and the payload, rather than using up the high efficiency stage during the phase of flight where the bulky and massive solid fuel boosters are still attached. Having 2400 delta V to spend in this stage after the craft has already passed through most of the atmosphere allows only a few hundred meters per second of the upper stage's delta V to be utilized for completing the launch. While I plan this maneuver, I think I'll go over what I'm actually doing since I realized I haven't gone over these Minmus transfers at all yet. Principia as a mod is definitely complicated, but when you distill down all the bells and whistles, the core mechanics are pretty similar. You of course have a display of your orbit and the ability to plan maneuver nodes. The maneuver planning is all done in this flight plan window. I assume the dynamic nature of the orbit lines as well as technical limitations are why you can't just click on the orbit to make nodes like the stock game. But if you've ever used a maneuver planner mod in normal KSP, the maneuver editor is probably not particularly groundbreaking to you. The main difference is in the mathematical rigor of the simulation. In the stock game, the only consideration for your orbit path is the spacecraft's position and velocity, and the body you're orbiting around, also known as the two-body problem. Your orbit in stock KSP will never change unless you order the sphere of influence of another body. These spheres of influence are just arbitrary approximate distances where the gravitational force from one body is greater than the other. And to keep the physics simple, the game decides to switch its math from focusing on the first massive body, such as Kerbin, to a new massive body, such as Minmus. All trajectories in the two-body problem take the form of certain mathematical shapes known as conic sections, such as ellipses, parabolas, and hyperbolas, and this combined with how the simulation patches these sections together is where the name patched conics comes from. The logical question then becomes, how do we decide the way we're going to look at our orbit? If there aren't any spheres of influence, at least not ones that affect the orbit simulation, how do we pick what body the orbit should appear centered around? The key takeaway here, and what I've been building up to explain this entire section, are the frames of reference. Principia includes a reference frame selector, which is brought up with the plotting frame selection button. One of the challenges of the mod is picking the right frame of reference to use for the right task. In some sense, it's like driving a manual car, while in the stock game you're driving an automatic. The spheres of influence in the base game allows the game to kind of cheat in a sense a little bit. For example, if you're planning a Minmus flyby, you will see the planned trajectory with respect to both Kerbin and Minmus. Because there's a clear dividing line, the game can just show the part of the trajectory around Minmus a second time, but center it around where Minmus currently is. In Principia, you have to choose how your orbit is displayed. Inertial reference frames are how pretty much all trajectories are displayed in the stock game. The massive body is centered and the frame of reference does not rotate. That is, the path you're shown is relative to the stars. You might think of it like the real orbital path around a particular body, in that it isn't stretched or rotated. When planning a transfer to Minmus, however, the power of driving manual allows us to choose arbitrarily how we want to display the spacecraft's trajectory. I'm using the Minmus Kerbin Orbit, or MKO reference frame, and without getting too deep into semantics, it essentially shows what the path the probe takes would look like if we pinned both Minmus and Kerbin in place rather than just pinning Kerbin in place. You lose the ability to see exact distances of travel left to right with the accuracy of the inertial reference frame, but in exchange you gain the ability to see angles with much more precision, which is very important when you're trying to send off your spacecraft just so to intercept with this comparatively small target very far away from Kerbin. There are a myriad of reference frames throughout the game, but they largely take one of three forms. Body-centered inertial reference frames, or your normal orbit view. Frames that rotate with a body's surface, showing how the spacecraft moves relative to the surface rather than the stars. And frames that rotate as a body orbits, showing how a spacecraft moves between two bodies in a more straightforward fashion than the other frames can provide. Since this reference frame is centered on the line between Minmus and Kerbin, it is much easier to position the maneuver node in the right place and then add the delta V required for the transfer. It also allows you to plan maneuvers efficiently. You want the orbit to just scrape up towards the massive body where you want your periapsis to be. With that spiel out of the way, we can take this maneuver we've planned and conduct our burn to transfer to Minmus. It's not perfect, but I ended up correcting it a bit manually anyway, since I always forget that right after the end of the Principia maneuver time, it immediately switches to the next maneuver node, or just turns Smart ASS off, which throws me off a bit. Once we're in Minmus's sphere of influence, the spacecraft starts immediately collecting site data from the various biomes high above the moon's surface. At this point, I had planned to just return the craft to Kerbin straight away, but it occurred to me that I shouldn't waste such an easy opportunity, so I raised the craft's apoapsis into space high over Minmus, and did a few passes collecting data across its various biomes. After one final pass without particularly much new data to speak of, I decided to plan the return to Kerbin. I'm using the MKO frame of reference to get the maneuver at vaguely the right time, and I then fine-tuned it using the Kerbin-centered inertial reference frame to see the periapsis around Kerbin more precisely. As the craft hurtles back towards Kerbin, we managed to pick up some site data for Kerbin before finally retro-burning to dump the rest of our fuel, separating the recovery module from the rest of the spacecraft, and preparing for re-entry. Now, at this point, I struggled a bit trying to decide what to spend our 137 science points on. My main goal at the moment is to land a Kerbal on Minmus, but there are a decent number of parts that would be good to unlock first. I also have the SCAN Sat contracts for Kerbin, which will provide a good deal of science in their own right, so it would behoove me to unlock parts that could be beneficial for both missions. In the end, I decided to unlock the general construction and specialized construction techs, primarily to get access to launch clamps and aerodynamic fairings. Since fairings mean oddly shaped rockets are no longer immediately doomed to failure, I set to work building a very basic SCAN Sat with the parts available right now, including an R3B radar altimeter and MS1 multispectral scanner. These scanners together provide biome data as well as low-resolution altimetry and visual scans. They also both perform optimally at 105 kilometers. Since that's considered low space around Kerbin, it's an excellent craft on which to sneak the Magnosity Ionospheric Transmissive Evaluation, or MITE experiment, since it provides new data above each biome in low space, can only be run on atmospheric bodies, and requires an inclination above 70 degrees. Launching this craft was very straightforward thanks to the aerodynamic assistance of the fairing. Once in space, the scanners and experiment were enabled and the antenna was extended. After some tinkering to figure out why the custom tracking stations the mod devs dotted around the map weren't working, I headed into the tracking station to await the precious data. When the contracts were completed, we unfortunately still had a disappointing number of science points, but we'll just have to move on to what we're doing next. With that objective finished, I still wanted to generate some extra funds, so I headed back into Mission Control to see what was on offer. I don't want to take any contracts for the MUN until I finish our current administration strategy, so I ended up taking 2 contracts to transmit science data from space around Kerbin, and from the surface of Minmus, which we should be able to complete along the way. I also took a contract to put a satellite in a polar orbit of Kerbin that I didn't quite read the fine print on. And so I inadvertently tasked myself with making a much beefier satellite than I had anticipated. I ran the numbers, and a Hohmann transfer from a circular orbit at 95 kilometers to circular orbit at 77 megameters will require just shy of 2,000 meters per second of delta V, so nothing to sneeze at. Luckily, the payload for this mission is very small, just a probe core, a battery, a reaction wheel, the mystery goo container, an antenna, and a few solar panels. The actual guts of the craft under the fairing have a combined mass just under 300 kilograms. The upshot is that getting into orbit won't require a much more complicated craft than what we've made before. In this case, a lower stage with a swivel aided by 2 small SRBs, and the upper stage powered by the Terrier engine. The first burn to send the craft out to the apoapsis of its target orbit requires about 1500 meters per second of delta V, which will consume the majority of our remaining fuel. During the maneuver, the craft didn't have signal, so I could only run the engine at full throttle. After the maneuver, I time warped until the probe was connected to a ground station and made some fine adjustments, as well as updated the flight plan. After a 45-hour coast, we get up to the apoapsis of our target orbit and boost the periapsis up with a 358 meter per second maneuver. At this point, I started planning a correction maneuver to get the satellite right up to the orbital parameters specified in the contract. However, after wasting a few minutes working on that, I started to time warp to it, just to notice the contract window flashing, which is a good reminder that sometimes you can be obsessively precise when you shouldn't be. This is a good opportunity to have a look at the wonders of Principia, since this satellite's orbit ventures pretty far from Kerbin towards that of Minmus. You can see an ordinary circular orbit with the current settings, but in the bottom right of the Principia menu, it indicates that the simulation is predicting 260 steps ahead. we can set it up to 1,000, 4,100, 16,000, and eventually even 66,000 to see very far into the future what the orbit of this satellite will be like. And as in real life, the orbit of this satellite is far from static. It's constantly changing bit by bit, especially when it's closer to Minmus. You can probably see through the video the performance taking a bit of a hit at 66,000 steps. These simulations are more computationally expensive, but you rarely, if ever, need to actually see 66,000 steps for ordinary flight planning. It's useful in niche situations to do what we're doing right now, analyzing the stability of an object's orbit over very long periods of time. Regardless, with some extra funds under our belt after that ordeal, we can move on to the real big step of this video. I still don't think the space program is quite prepared to land a Kerbal on Minmus, but we can take the next best step, putting a Kerbal in orbit around Minmus. There's at least one contract objective we can complete with a mission like this, which is to get science data from space around Kerbin. I plan to upgrade the astronaut complex so that our Kerbals can go on EVA in space for the extra science, so that shouldn't be too hard of an objective. Taking a Kerbal to Minmus has the same delta-V demands as a few of the missions we've just done. The real challenge comes from the extra weight we have to bring along. Not just the Kerbal, but the extra mass of the command pod, as well as the materials bay module I want to bring along. Luckily, this mission isn't particularly demanding in regards to life support materials. That will come a bit later. The design I eventually came up with is this. The launch stages are comprised of a central liquid-fueled section, this time using the LV-T30 Reliant engine for its extra thrust, since this stage will be discarded by the time that the fins are too weak to control the spacecraft. This is aided by 4 solid rocket boosters, which made this a bit finicky to fly as well, as the TWR has a tendency to shoot up very quickly after launch. After both the SRBs and the center liquid stage are depleted, there's a middle stage using a swivel engine, which has the oomph to get the payload just shy of orbit. The final upper stage, with all the goodies, has enough delta-V to circularize in Kerbin orbit and perform the transfers to and from Minmus. Luckily, I was able to find a good set of gravity turn parameters for this launch, and it went very smoothly all told. The upper stage got into a circular orbit with about 2,400 meters per second of delta-V remaining, so it expended only about 200 to finish the launch. At this point, I was thinking about the ways to get more science during the mission as well as complete that contract, and this was when I decided to go upgrade the astronaut complex despite the pretty high cost, at least as far as what funds we have available to us right now. This means that we can go back to our craft in orbit and experience our first steps outside of the capsule in the void of space. From this point, I set up the flight planning in the same fashion as the previous Minmus transfers, and while time warping to the maneuver, the craft regained signal, transmitted the EVA report, and completed our contract to receive science from space around Kerbin. Since this is probably the first mission bringing a Kerbal through the radiation belt since episode 3, I took a brief gander at them while the craft was on its way towards Minmus. Once we reach the descending node, it's time to do a small maneuver to fix our course on approach to Minmus, bringing it up slightly closer to the equator of the moon, and then getting the point of closest approach to a roughly suitable altitude. At this point, I also set up a maneuver to capture the spacecraft in a circular orbit around Minmus, as well as planning the ejection burn, since the flight planning window will report the overall amount of delta V required, allowing me to see that the spacecraft does, in fact, have enough fuel remaining for what we have planned. Once we're in Minmus's sphere of influence, it's time for Valentina to go on a brief walk again, this time doing some slow tumbling through space before heading back inside to record her observations. After getting into low space around Minmus, I enabled the materials study to get as much of the remaining science as possible from low orbit around Minmus, and performed the capture burn. After accidentally running out of electric charge in Minmus's shadow because the experiment was running, I time warped until the craft was in the sunlight again so that Valentina could take yet another spacewalk out where she could get a real close look at whether or not this was, in fact, a gigantic blob of mint ice cream. By the time we get to the maneuver to return to Kerbin, the materials study has collected all of its science from low space. There's a bit more science from high space over Minmus that we should be able to collect as we depart. While on the way back, I planned a maneuver to dump the rest of the fuel to kill a bit of the entry velocity. I also enabled the radiation belt display again, and I found that it's somewhat easier to see from this distance where it's all visible in one place. When we're surprisingly only minutes away from re-entry, Val takes one final jaunt about in space, bringing the samples from the materials bay back inside the capsule for recovery. After an intense and frankly dangerous re-entry, Val's little protective bubble manages to slow itself down to a suitable speed before the parachute deploys at 0.4 atmospheres. I should honestly set the parachute pre-deploy a lot lower to say 0.25 atmospheres now that I've actually seen the atmosphere info panel during the descent. I should probably only leave the main chutes at 0.4 when there are drogue parachutes doing some of the early brunt work. After Valentina has a bit of faffing about in the water so that I can squeeze another EVA report out of this mission, we return to the Kerbal Space Center with over 100 science points in the bank, and with Valentina having earned an abundance of ribbons for her efforts. The last orders of business are to see what may be in store next time and see what we want to unlock with our science. The mission control offered a few good contracts. The first is a contract to get science data from space around Minmus, which seems kind of insulting to be offered at this exact moment, but I have a plan for what experiments we can do. The second is a rescue contract, the first one we've been offered thus far, likely since we unlocked the ability to conduct EVAs. Over in the R&D building, I had trouble deciding what exactly to get, but eventually settled on the fuel systems technology for its additions of a large radial fuel tank, the fuel line parts, and a number of additional larger fuel tanks that will be more useful as we go on. With these new contracts and parts, it seems like a lot of our work next episode is cut out for us, and I hope to see you there as we continue along with our goal of putting a Kerbal on Minmus before the decade is out, as they say.